Another terrible American. Sorry, here we are. But excited to be here today. This is important stuff, and I really love the conference title. Iteration really is in the lifeblood of what we do at Hermeus, and we'll touch on that throughout the presentation. But we're all here for basically the same reason, right? We're building complex hardware, so I don't have to go into all the difficulties associated with that complexity within engineering. We all know those. We live and breathe those every day. I also probably don't need to go into the funding difficulties associated with funding projects like this that are long-term, big picture, big swing things that you have to iterate through and you have to get there over time. What I want to spend today on talking about is something that's been touched upon by all of the speakers, and it really is culture. And so the notable point here is when Toyota was developing the Kaizen, the lean manufacturing principles that enabled their success, they tried to export those to other vehicle manufacturers, and were unable to reproduce the results even with the exact same processes. So really what that came down to is how the people interact and what is the culture of doing exactly that. And for us, it comes down to hardware, obviously. That's why we're all here. If you're not building the systems, then you're not really doing it. But it also comes down to the people and how these people interact. And that's something we spend an enormous amount of time thinking about. And so today I'll be presenting some of the experiments that we're taking, and they are just that, experiments, because at every phase things are different. But a little bit of history on the company, just so you know what we're doing. There was a great intro there, but a little bit more about some of the challenges associated with what we're doing.
If you don't think what we're doing is crazy, you probably don't get what we're up to. We're developing a hypersonic passenger plane. This would be by far the fastest reusable aircraft ever. It will shatter the record held by the legendary SR-71. This technology will change how goods and people move around the planet. It effectively makes the world regional. New York to Paris in 90 minutes. LA to Tokyo in about 3 hours. We've done the research. By speeding up global transportation 5x, you're looking at $4 trillion of new global GDP growth per year. But this is going to be very challenging. First of all, we have to invent an engine, one that can operate efficiently at standstill on a runway up to Mach 5 at 90,000 feet. When we're going that fast, there will be sections of the aircraft that are at 1900 degrees Fahrenheit. That's hot enough to liquefy aluminum. Our airframe must withstand these temperatures, all while keeping the cabin safe and comfortable for passengers. And then, we have to get it certified by the FAA. Are we sounding crazy yet? Well, hold on. All of this has been done before. Kind of. Before Neil Armstrong went to the moon, he was flying faster than Mach 5 back in the 60s. Modern materials are proven to withstand these temperatures. And ramjet engines, which can go up to Mach 6, are well understood. The trick is bringing the component technologies together. Hell, what's harder than the tech is obtaining the capital. But we've got a plan for that too. We've already raised over $100 million of private capital. And more importantly, we have access to huge intermediate markets with the government. What this means is we can sell small, uncrewed aircraft on our road to commercial passenger flights. Our team is small but highly motivated and experienced, with alum from SpaceX, Blue Origin, NASA, GE, Boom, Boeing, Sandia, and others. So if you've got the chops and are eager to break speed records, head on over to our website and apply. Race you there. Race you there.
So apologies for those bad dance moves, but we like to have fun. So when we're talking about culture, it really has to start from the overall mission. That's the thing that people see first. It's what they latch onto. It's the reason that helps them be motivated when the days are hard and long. And so for us, it's radically accelerating air travel. And so this is not incremental. This is not a little bit faster. This is massively faster. And this is how we think about everything that we take on, what technologies we go after, what contracts we chase down. And this is really the starting point of everything that we do. And so it really serves as our North Star at every step of the way. And I'm sure everyone, especially the folks who came in from the States or maybe even farther away, can appreciate. I really wish planes were much faster. It took a long time to get here, and I'm going to continue telling that bad joke because we all understand the plight of being on an airplane. No one wants to do it any more than they have to. So iteration is really part of the process for this. So again, from the top down, I'll briefly touch on this, but you can't do everything all at once. You can't go sell commercial passenger-carrying aircraft out at the gates. So how do you get there? So we're taking an incremental approach that incrementally bites off tech risk, but also serving markets along the way. So our first vehicle, Quarter Horse, is basically a system to prove the engine technology in flight. It is massively de-scoped in terms of requirements. Then moving that on to Dark Horse, which is the next step, another uncrewed platform about taking on some long duration flight, being able to keep a cabin area safe and comfortable for a sensor or a payload. And then at that point, we'll start to understand the maintenance, repair, and overhaul of these types of vehicles. All of this is done without flying people, so avoiding some of the regulatory challenges associated with building systems like that. And then as we move on into Halcyon, we'll have the technical chops associated with building and developing and maintaining a commercial passenger aircraft that is safe and comfortable. So just a little context for where we are as a company to kind of anchor what I'm about to talk about in terms of our cultural experiments. So as the video mentioned, we've raised $100 million in our Series B. And we're starting to cross the threshold. We're gaining credibility. And I think a lot of that comes down to what the engineering team has been able to accomplish from the hardware perspective in a very, very short timeline. A couple of notable products that we built, interim products, I would say. The first was we wanted to build a mock-up. In aerospace, it tends to be an exciting thing just to see the sense of scale. So this is about 40 feet long, about, I don't know, 12 meters or so long. And that's a full-scale mock-up of our first aircraft. But we wanted to do something that made it more impactful. So we had an event. We brought in some potential investors, some potential government customers. And rather than just have a fiberglass mock-up that was inert and boring, we're like, all right, we like to make fire. Let's put an engine in it. So we put an engine in it. And so not only was it a great marketing piece, especially with investors, they don't always get to be around stuff that's very, very loud and very, very hot and a little bit scary in a safe way. But we were able to also get an at-bat, an iteration at building a system as a whole, getting everyone together, working through the fluid interfaces, working through the hardware interfaces, the structure, the avionics, the software, the operations associated with, and it provided an enormous amount of learning in a relatively benign and de-scoped way. And then here down in the bottom right, you see our engine in our test cell in Atlanta. We're currently in wind tunnel testing of that system, all in-house developed hardware around an off-the-shelf turbojet. I'll talk a little bit more about vertical integration later, but this here is, exciting news to come out very, very soon about what that's capable of, but that's called Chimera, and we'll go in our first aircraft. So in terms of the company size, obviously that's what we've raised so far in terms of our Series B, but also our 85-person company, so that will be kind of the focus of how we've developed some of these cultural pieces. If you were 300 or 1,000 people, it might not make sense. So it really starts at the most upstream possible. How far out can we go in terms of starting to tell our story and finding the right type of talent to be able to produce these systems? And so there's an assortment of things on here that we're trying to do. You'll see some TikTok videos, some swag, all the kind of basic marketing things. But it's really to start telling our story. It's really about being as transparent and authentic to the point that we can in terms of how we approach problems, the types of people that we're looking to find, because it really isn't for everyone. The startups aren't for everyone, and even our approach to hardware startups isn't necessarily the traditional way. One notable point I want to call out here is we do have a podcast where we are able to go into longer form conversations about what we're doing, which is pretty exciting. There's not a lot of places you can do that, and for something that is very, very complex, it takes longer than a soundbite or a sound clip that you can put in a news article or a video, a short video. So being able to do those longer form conversations about the tech, about national security, about diversity, equity, inclusion, these really, really complicated things that take a lot of nuance to explain, it's an outlet for us to be able to explain what we've been spending time about thinking, but also things that we don't have answers to. And so right now it's pretty small. Most of them get around a few hundred views. And some of the other ones, especially when we had some SR-71 pilots on, that one got a lot more because that's pretty cool. A lot cooler than what I'm doing, definitely. But the kind of important thing here is less about the numbers and more about the targeted niche audience that we're trying to tell the story to. And so getting a lot of great industry feedback from that. So I definitely recommend it if it doesn't take much time to spend an hour chatting, just face-to-face, say what you're thinking, and then get it out into the world. So then once people are interested, we really need to tailor our process to making sure we're indicating to them that we are caring about people. And the way you do that is by actually caring about them. So during our typical interview process, both of these come directly from our website. We're trying to set expectations about what we're doing. So there's no surprises, and really just trying to develop as much comfort for people as possible. We don't want someone to have a bad interview because that's not the day-to-day that they're going to be working in. So setting expectations, getting them as comfortable as possible, and then providing a clear outline of what the benefits of be working there aside from the mission. As much as a mission, it would be great if we could just fight the good fight and have a very exciting mission and that be enough. I mean, people have lives and people have things they are seeking at an individual level, and so being able to call those out as much as possible. These are all pretty standard stuff, but really just trying to set those expectations up front. One other interesting experiment that we did was early days. So our CEO was on a podcast one time and said, we're not trying to fill a company with resumes, we're trying to fill a company of people. And so what ends up happening, especially early days, is you make all these job requisitions. They're very specific. They're very tailored to specific types of subject matter expertise, which is obviously very important. But it could eliminate very, very talented or qualified people that don't necessarily fit exactly into that requisition. So we started off with basically hiring buckets associated with generic forms, like what team would you join? Are you going to join the structure team? Are you going to join the fluids team, avionics? And so by doing that, it allowed a lot different types of people and people we may not expect, so we were able to find value in a non-traditional set of background experience. We're starting to add in more traditional requisitions because as we're getting farther along, we need kind of very specialized analysis techniques or similar. But it was a really, really cool thing to be able to just see what was out there and see that there's a lot of really cool talent that isn't necessarily fitting into a traditional discipline. So now to dive into what are we doing internally. So we have three major areas. There are many other things that we're doing on a day-to-day, but I want to talk very simply about the top level here. So the first one is virtues. This is really what we kind of expect from an individual. This is how we go about our 360 reviews. This is how we think about how people should interact within the company. And then I'll dive into the tenets. So these, I would say, are more like our biases. So when things are very uncertain, as it is with everything that we are doing because of the complexity, there isn't always an obvious answer of the make versus buy trade. There isn't always an obvious answer for which decision to go with. So this is, in those very, very uncertain times, quick ways, heuristics that allow us to move in the right direction quickly, so to avoid the paralysis there. And then our parables. And these are really, they are parables. They're just stories that we would like to embody that aren't necessarily related to aerospace, that are indications of how we would like to be without specifically saying, do this and do that. So I'll dive into a few of each of these very, very high level. So within our core virtues, there were aspects of these in all of the presentations, so we're not really finding anything new, it's just kind of how we're laying them out. Speed is an obvious one. When you've raised funds, the clock is always ticking, so there's the aspect of speed that is kind of financial, and there's definitely a wrong way to do speed, right? If you're letting quality slip, then obviously your work products are worse, but I would argue that that is actually counter to speed. If you're making things that break recklessly, it's actually counter to speed. On the accountability side, for everyone here who has been a part of a small organization, there isn't a backup option. There isn't always someone to be quality assurance for you, so you need to be individually accountable toward it. On the decision-making side, as Ben was really talking about on the first principles side, that's really where you have to start your decisions, is from first principles. When you're doing something that's never been done before, you can't do it the same way as everyone else. And so starting from those first principles allows people to make intelligent conversations happen. And then on the teamwork side, no one is a specialist across enough disciplines to do this alone. And so really, the ability to work together is absolutely critical. So what is explicitly not called out here is technical experience. One, there's not a lot of technical experience in hypersonics specifically. I think there's something like fewer hypersonics engineers than Bengal tigers in the world. But it's based on the same sort of fundamental principles of anything in aerospace. And really, technical experience is embedded within each of these things. So we can't have technical experience at the expense of teamwork, say. So on to our tenets or our biases. So really vertical integration. So I think new space has shown that this is helpful for managing schedules, but there's also, like I said with speed, there's a right and a wrong way to do vertical integration. Obviously vertical integration, especially in manufacturing, can be quite capital intensive. And so with vertical integration here, it's really on the development phase. It's if we need to be experts at it, if we need to build something in-house from scratch, that's when we vertically integrate. If something great exists off the shelf, well, maybe we just go buy that. But really, it's in those trades where we need to make decisions across an interface. By owning it in-house, we can manage the schedule, we can manage the supply chain a lot better, and make those trades at the system level when things are very, very coupled and complex. Driving to test quickly, I'm sure we're all very familiar here with analysis paralysis, which can definitely happen. And there's a tendency and a draw, even I've spent years and years thinking about this, and I get pulled into this from time to time. But by driving to test quickly, you are finding those problems at the interfaces, and then you're able to improve the system over time to the point of iteration, which I'll touch on at the end. But also, just by having driven to test quickly, you also have products that are integrated, and you're building the team, you're building the machine that builds the machine over time. On the hardware richness side, additionally with the analysis paralysis, you can't always predict something a priori of how it's going to perform. In very, very complex environments, the simulation required doesn't get you within the performance that you need, and is really, really hard to predict out the gates. So making the decision to potentially have some variants of the same hardware where you can quickly swap them out and just find the optimal. You can just go look at it directly, save some time. Also, you're not going to get it right the first time. Our first aircraft quarter horse for the development program, we're building 3 of them. So not quite what SpaceX is doing with Starship and blowing them up every other week, but somewhere in between that and versus building one and having it to work the first time perfectly. So having some spares to be able to not nail it the first time, ideally not recklessly, but really while you're figuring out how all these things go together. And then finally, iteration, and specifically a crawl, walk, run into iteration. So you know, the first time, something I like to say is, even for the software tools that we're building internally, what is the dumbest version of this thing that we can build right now? Because it will add complexity very, very easily. It's always easier to add more, but it's really hard to take it away. So starting with the bare bones version and iterating over time and adding in more meat to that system. On to the parables. So I'm sure many are familiar here with the very famous Japanese beef, Wagyu. The idea here is if you take a different sort of approach, or if you take a very specific approach, you can do things of very, very high quality, very, very fast. And so, you know, with this cut of beef, it's very, very expensive. So you're spending aggressive amounts on the thing that matters the most. But with the other additional ingredients, you know, it's salt, it's a little olive oil. Those are both relatively cheap compared. And so it really comes down to your process. It's, you know, you mise en place, you have everything where it needs to be from the beginning. You go through the process, you're very intentionally searing it on either side to get the exact temperature for the exact time. You let it rest. While it's resting, you clean up your plate, you clean up your pan, you re-oil it, and it's ready to go for the next. So that entire process could take 15 minutes. Now, counter to that is something like a stew. Stews are great. They have lots of ingredients. They take a long time. They're very good for a different situation. That's just not the company that we are trying to build. We put out a video. It was a spoof of Ocean's 11 that we put out. It took a day. We had a production crew come in. It was pretty fun. And so you should go check it out on YouTube if you haven't seen it. So Ocean's 11 Hermeus would be how you find it. But something this team was saying, given that they're from the entertainment business, was go Hollywood it. And what was interesting about that is, you know, within Hollywood, you know, you're building a movie, you're building a production. Everyone on the team has a very specific role. Everyone knows exactly what their specific role is, and they have to be an expert within that field. But there will come a moment when something you don't predict happens. There'll be a harsh shadow cast across the face of an actor. And so sometimes the makeup artist needs to take a light and just hold it in a way and Hollywood that light. And so that's the idea, right, is be a specialist, do, you know, everything you can to predict, but there will be unpredictable things, and it's all of our job to make this airplane fly or to make the movie. And so making sure that we're all motivated toward that end goal. Our only aerospace one, there are lots from the industry that are really, really exciting. But P-80 was the first jet aircraft that was ever operationally fielded. And the impressive thing here is the team was about 130 people that were working on this. The intended timeline was 180 days from nothing to operationally fielded system. So within a very, very small team doing something that had never been done before, they actually came in left of schedule, 143 days. And really what that came down to was an approach, a culture, and by having this example as an executive who, twiddles his thumbs and sits back and looks at the the floor and makes, hey, you need to go faster. It's like, well, they did it, so it gives me a little backup to be able to say it's possible to move schedule to the left. So it's the Cold War era. The doomsday clock is precariously close to midnight. Everyone is tense, thinking nuclear war is imminent. And a Soviet intelligence officer is watching a system that is a relatively new system, and all of a sudden, he sees one ICBM fired from the United States. His name is Stanislav Petrov. He sees another one. Eventually, there are 5 ICBMs coming at the Soviet Union, and something in that moment, he didn't believe it was accurate. His direct orders were to elevate that no matter what, to his superiors, and the response would be send the entire nuclear arsenal against the United States. But in that moment, something was just not right. So he didn't follow orders. He disobeyed direct orders to send the nuclear arsenal towards the States. And in doing so, saved the entire world. It turns out it was a false alarm. Now, that was a gut feel. And there is times when a gut feel is right, but when the stakes are very, very high, you really, really, really have to be right. That is obviously the highest stakes possible to make a gut feel to call like that, but he ended up winning the Nobel Peace Prize for it because he literally did save the world in that moment. So a few slides here on some of our iteration. But like I said in the beginning, all of these cultural things are just meant as creative ideas for all of you. What works at one scale of company won't work in another scale of company. What works at one tech set won't work in all the tech sets. I mean, I could come back next year and have a completely different set of principles for the cultural aspects that we're trying to convey. So really, thinking of it like an experiment is really important, and trial and error and figuring it out and iterating not only in your hardware systems, but also your culture as well. If you spend a lot of time thinking about it, I think you can do some really, really impressive things. And it'll be exciting to see what each of you work on by paying attention to those things. Thank you.
Thank you very much. I think it was really interesting how your talk came straight after Bill's. And Bill spoke about the death valley between, these very clever, intelligent young people on one side of the valley, and then these more experienced, senior people that seem to know everything. And I think we can all safely say that your company is more shifted towards the younger people on that side of the chasm. There wasn't a wrinkle in sight in some of those people that we saw pictures from. Okay, now we can open up some questions to the floor, if anybody has any.
Thank you for the presentation. And I would like to know how you develop an MVP in such a field with high entry barriers like the one you're developing. Thank you.
So for us, it really comes down to scope reduction. So to the story of Wagyu, by throwing away absolutely everything that doesn't matter at all and focus solely on the things that do. You can't do, there's a minimum amount of time it takes to, like, say, build a harness. I come from the avionics world, so that's what a lot of my examples are. But there's a minimum amount of time to reach a level of quality. But if you have to build fewer harnesses, that's how you save time. So massive scope reduction and really breaking some of the assumptions. So one thing that I didn't really talk about is that because we're an unpiloted aircraft, we can push a bit more risk into the flight campaign because we have backup options in terms of airplanes, because there's no people on board that we're risking. So we're de-scoping some of the upstream work of all of the very, very expensive long lead time wind tunnel testing. So we're doing subcomponent wind tunnel testing and bringing it together and sort of intentionally trading across those risks in order to reduce the amount of effort necessary to get into flight, but by holding some of the bare minimum necessary steps along the way.
I have a question. Sorry, a bit loud. What's harder, going hypersonic or getting more views on your YouTube channel?
Oh, man. Well, I will say it's actually probably harder the YouTube one because we spend very little time thinking about it. So I'd say we spend a lot of time thinking about hypersonics, so I'm much more convinced that we will be a hypersonics company before I'm a YouTube celebrity.
If anyone's willing to take that bet, then I'm sure there's some wagers we can make.
Get those clicks going.
I'm not too familiar with the history of the company, but a lot of your founding team was in Generation Orbit. Was that an experiment that you learned from that made Hermeus is what it is today, and what did you learn? What did your team learn from that?
Yeah, so Hermeus, or before Hermeus, yeah, I met my other 3 co-founders at Generation Orbit, where we were building a hypersonic rocket plane for the Air Force, the US Air Force. And the idea there is that, like I mentioned, these long lead, high-speed wind tunnels on the ground, very expensive, very long lead. And so the idea there is it's cheaper and faster to strap a rocket to the back and get that up for testing. So the niche that we found was within the Air Force. And so it was also the first iteration of us leading a company. So I was the director of avionics and software. 2 of the others were technical directors as well. And then the CEO of that company is the CEO now. It was a subsidiary of another business. And so that gave us a first iteration, a first at-bat at building a small company and getting hardware into the field with too few of resources. Not enough money, not enough people, not enough time. And so that gave us a foundation. So we had a lot of that, but we're certainly beyond that point now in terms of our scale. So we're still learning new things all the time. And then on the other side, it's like working with those customers, finding intermediate markets. That is something that's always been core to our business. I think it would be very, very hard to go raise money on a passenger hypersonic aircraft out the gates, and then having the technical chops to support it. So by understanding how to work with the government as a startup and starting to see that mind shift where governments are starting to be open to these type of projects and start to write larger and larger checks in higher risk environments, gave us confidence to start this company.
I'm curious, you spent some time talking about how you get those good people that you want to hire and that it's not so easy to get people with the experience. Then you also talked about that there is a point where you need to give accountability because there's a limited amount of people. How do you go about onboarding? So basically, once you found that great person and that you have the trust in, I mean, there's a lot of work that has been done. There's a lot of things that need to be learned quickly about what you've built, where you're going, and then also the technical knowledge about what has been tried before, what worked, what didn't work. How do you transport that information to an ever-growing, fast organization?
Yeah, so on the experience side, it's not that we don't want to. There's certainly, it would enable us in a lot of ways. I think where experience can go wrong is in the comfort with uncertainty. And I also generally try not to say experience. I like to say exposure more. We have a guy, actually a friend from college who just recently joined our team, who was a director at SpaceX and had seen literally every program that they had worked on, the largest rocket in history, the largest satellite constellation, all the different iterations of a manned system and an unmanned system. So, you know, having a lot of exposure is absolutely valuable to us, but it's making sure that the right qualities around uncertainty, risk management, and moving quickly are there. In terms of onboarding, it really starts, as I mentioned, just as far upstream as possible, setting expectations about what type of company we are and what we value so that we don't waste anyone's time when they come in being surprised about how we approach all these problems. So I think it really starts there, and then as people come through the process, it's just continual conversations. It's like you can't have enough conversations. Every failure of culture that I have been a part of or directly caused has been because of a lack of communication and re-anchoring to those cultural important things.
Yeah, still on the hiring, I saw in one of your early slides the hiring process. There was one step that was group project or something that involves more, the team. Can you elaborate on what more of that is, and how long will a, successful process take on average?
Given that speed is one of our core tenets, or our core virtues, getting people through as quickly as possible and responding very quickly. So I think it probably takes maybe a month or 2 at this point, and that's really more schedule management than anything. People could be, the technical people doing the technical work can't always be in interviews, right? So it's just it's a little bit of a balance there. But in terms of the group project, it's really trying to understand how people work in groups. So it'll be something like, some companies will call them Fermi problems, but these, not necessarily like how many golf balls are in all the windows of New York or whatever ridiculous thing that is, but something engineering related. So it's like, what would it take to terraform Mars, right, is an interesting one that gets you to first principles. So it's getting to this thing that you don't know the answer to immediately. And then whiteboarding it and working through it and poking questions and then allowing people to see their thought process when the answer isn't obvious, because that's most of what the day-to-day is. So it's really trying to put people in the environment that they're most likely to be in, which is really, really hard any other way.
big things fast. We're well funded, but not like infinite funding. And you're onboarding all these people. What tools do you use that you like, and what tools do you wish you could have that don't seem to exist?
Yeah, I think it's really pointing people to the single source of truth. It's been in many presentations at this point, but quickly getting people to know where to seek out their own context is probably the hardest part, right? If there's a very obvious but flexible place to be pointed to, that is usually the place where people spend the most time spinning their wheels, because they have to ask a bunch of different people, oh, where is that document, or where is that piece of information? So I think that's the biggest one. And then the next one is just getting people into the environment where they can start executing once they do have the context. And I think really with systems engineering, that whole way of approaching the problem is really contextualization. So it's like, how do you contextualize and simplify complex information as easily as possible without requiring an enormous amount of work to set it all up?
Okay, everybody give it up for Skyler Shuford.